Okay, so first of all, I want to begin with saying thank you to AT&T and Ericsson for putting this event together. It's like it was a lot of effort, and then when those guys came to us, it was like the event was in the beginning and infancy, and then it has come together such a nice one also. So that's really nice. Isn't this amazing event so far, guys?
Yeah.
You guys had lunch? Okay. So for me, the exciting thing was that this was one of the events which I've seen where all the small and the large companies coming together. And then Kirk, Chuan, and Scott, we were having lunch together, and then we're trying to see how we can fight between each other. And we learned that we can't fight. We need to collaborate much more because it's such a hard problem to solve. So we're actually talking about HD mapping and all those sort of things. And what I want to begin with saying that from my perspective, I'm the token OEM guy, the car guy, and we have 3 HD mapping guys. At Toyota, so I lead one of the connected car division for Toyota, and we actually love collaboration. And with AT&T, Ericsson, Intel, a lot of other partners, we have put together a consortium called AECC, which is called Automotive Edge Computing Consortium. And they were asking me, like, why do you really need 5G and edge and scalable map and all those sort of things? What I want to talk for just 5 minutes is that 2 very specific use cases for us, why is this so important. And then for us, actually, it's not an either-or problem. It is actually a must-have problem for us, and I'll explain why is that. So when we did the AECC consortium, we're actually looking at, you guys know that there's something called autonomous vehicle and connected vehicle. Autonomous vehicle is something which has a level 5 autonomy. It can drive on its own. But then all autonomous vehicles have by necessity are connected vehicle. And all of our car in next 5 years is going to be connected vehicle also. So connectivity is extremely super important. And when we look at all the maps, and these guys probably know the numbers much better than me, by 2025, it's going to be 100 million or higher connected vehicles on the road. So your and my car may not be necessarily autonomous vehicle. It's going to be a connected vehicle for sure. So one of our use cases is that when we're trying to collect all the data from the sensors, it could be humongous effort, almost like a terabyte per hour, to go to the cloud and all those things. And the vehicle-to-vehicle connectivity and all, the whole latency will kill us if we can't have 5G and edge computing and all those things. So it's not an either-or problem for us. It is actually a must-have problem for us. That's what I want to say. The second thing I want to say is that the standard definition map, which is like the routing thing which we punch on the Google map and say point A to point B, it is very different problem than the HD map. HD map actually really require very, very precise localization, almost to the standard of few centimeters. Right now, the way the localization works on current cars, you actually have 5 to 50 meters, which is pretty humongous problem. So if you use the SD map for autonomous vehicle or connected vehicle for the future, it's going to be a very, very unsafe scenario for the future. So with that, I'm going to open it up to our 3 panelists with a question saying that, just a brief introduction about yourself and say, what really is HD map? Is it really a big problem? Is it same as SD map trying to punch, or autonomous vehicle trying to punch point A to B by themselves? Or it's completely different thing or so.
Sure. Yeah. I'll go first. So I'm Scott. I'm a CTO and co-founder at SilMaps. We've focused on how can we create scalable approaches to this HD mapping problem. So why is the HD map important? I think you can think about it in 2 ways. One is the HD map as a sensor. So if you're currently seeing things with camera or any other sensors, you can also see those same types of things with a map. So if you know where you are on the map, you can know that there should be a traffic signal in this direction. So if there's a truck or something blocking that traffic signal, you have another way to view that traffic signal and also check your onboard sensors. The other way you can think about the HD map is sort of, I like to think of it as like train tracks. So if you're trying to go from A to B, really the HD map is train tracks that you're just sort of following a path through the area. And instead of having to understand all the complexities of the road, you just sort of have to follow your path. Mm-hmm. So I think those 2 things enable, are a very key part in AV and ADAS as well.
My name is Chang Yuan, so I'm CEO co-founder of Foresight AI. I just want to add on to what Scott mentioned. So the reason for having or needing the HD map is that now we're talking about robots, understanding the world in a semantic way. So where can I go, which lane am I at, and where should I go? So think about how we drive our cars, because we actually have other things studied, so I know these numbers. So usually we keep about 25 centimeters between our vehicle to a lane mark, to the left of us, to the right of us. So that's why we're talking about 10 centimeters or even better, because if your lane mark is off, then your vehicle doesn't know which lane is that, so I may drive on the lane. So that's why we need a high definition, also need the robot to follow that. So that's one thing we're looking at. The other thing we're also using our technology to extract the data from is how people drive on the road. So we have a term called a driving scenario, which I explain later. It's more about observing how people drive on the road. So you know where you are, where the lane is, how the vehicle drive beside you, how do they change lane, how do they change lane in an abrasive way, all the things that you can learn. You drive in LA is different than driving here. So all these things, we also want to capture those data and use it to train the autonomous driving system. So for our perspective, we provide a map, which is a really important, essential element, and we also provide driving scenarios as another way to train the car. In the end, you want to train the car drive like human, or at least has seen all the crazy stuff human has done and try to stay away from it. So in that case, we provide this driving scenario database also to teach the autonomous cars.
Cool. And my name is Kirk Mitchell. I'm Senior Vice President with Here Technologies. Here Technologies is a company that's been around for about 30 years. It has been helping lots of different consumers and businesses in a whole lot of different areas and location. We've been involved with many firsts over that time. We're the first company to help the embedded navigation system, which is a standard definition map in the early 90s, all the way through the first internet-based mapping systems, and then, of course, in the smartphone in the past 10 years. The way we see things with regard to your question, Prashant, about the standard definition map versus the HD map, SD mapping was really evolved for, a consumer being a person, a human. Really, HD mapping for us is very much a machine-to-machine problem to solve. So we're in an interesting situation where we definitely leverage the SD map. So all the attributes we have about road names and geometry and administrative boundaries, we use that as the underpinning for the HD map. But ultimately, and that's a nice legacy to have. At the same time, we want to completely revolutionize the way we think and design an HD map. And we're doing that with automation from the very start, because the issue we have with HD mapping is also one of which maintenance and updates as well, because things erode very quickly. And so it's been designed very much from the start to be a data set which we collect differently, but more importantly, maintain it in a different way as well, with machine to machine as the key goal there. So the company itself has been around 30 years, about 9,500 people globally, publish maps in 200 countries worldwide, so it's been doing some stuff.
Thank you, guys. A nice plug for all of your companies. That's very nice. I want to mix it up with a question that we all agree on one point, that HD mapping is a very hard problem to solve. And also it's needed, and we're going to discuss for the next few minutes that it's really needed and why. In terms of your understanding from each of you, what is the single most bottleneck at the moment, the technology-wise, to solve from the HD mapping standpoint?
I'll kind of have three main ones. One is, how can you create that HD quality and accuracy at scale? I think the current industry way to do it is to use survey vehicles and go out and paint ground control points and then use that to ground truth your data. I don't think that's going to scale to globally. So I think that's the first problem. The second problem is, how can you keep the map updated? We do have a lot of sensors out in the world currently with cars and cameras. How can you take that data and register that to the ground truth HD map so that you can update it effectively? I think that's the second one. And then the third one is, you need to be able to localize yourself on the map. So that means, okay, within 10 centimeters, 20 centimeters, where am I on the map? Because then it actually has use. And the problem right now is, how do you send that data down to the vehicle so that it can compare its LiDAR data, its camera data, with a reference map to place it on the map? So I think those are, and that's more of a network problem. So those are the three big problems that I see.
So scaling, keeping the data fresh, and localization.
Localization and sending the data, yeah.
What about you, John?
Yeah, sure. I think that's already 3 major problems. I'll add more. So I think one thing that we, from the history of cartography or making map, is that there's a lot of human efforts. So back in the day, people use airplane, take a picture of the road, then they draw the road, and then combine them into the map that we use. Still, maybe 10 years ago, we go to a new place, we get a map from AAA Club, if you still know that, what that club is. So that's the effort we're still doing now. We actually have to kind of really automate this. So right now, different companies have different automation. It ranges from 80%, 90%. We really need to push it to 99.99% so that we can really make this scalable, as automated as possible. So that's the fourth problem.
Definitely some great topics and points made there. Scaling for us is also the big issue, really, at the end of the day. For the next major advancements, whether it be level 3 vehicles coming out very soon with that capability, the expectation to be able to do this on a global scale is huge. And so, that's a key issue. I think we talked about it over lunch as well, standardization, just like in the infrastructure business with carriers and telcos, infrastructure standardization is critical. It's going to be very much the case also around mapping, in this case HD mapping. If you look at the 90s in standard definition maps, it really wasn't able to grow until there was some standards set in terms of how the map is in that case, it was a piece of media and how that was transferred between different bodies and partners, how you collected, et cetera. So there's quite a bit of a standardization effort we need to break. There's 2 ways that's really being addressed. One is the sensors. I think Scott mentioned, maintenance of these maps is really key. And obviously, a vehicle has many sensors on that, and there's a lot of interaction and data you can receive from that. But of course, if there's no effort to standardize how that basically is translated, that's certainly very difficult as well. So sensor standardization is one, and the actual map itself as well. There should be, at some point, an effort to try to get some kind of standardization there, because ultimately, we're all looking at this industry, automotive companies to start with. It's in their interest to make sure there's a constant standard there, that they're able to actually take multiple different vendors and have people compete for that business. So these are some of the basics that are coming through. I think one thing too also in terms of, there's an expectation issue at the moment as well. Like, 2 or 3 years ago, this was a very hot space, and still is hot for those in it. But these things take time as well. It's a big problem to solve. And I think also, really in terms of addressing some of the key things, we looked about sensors. At the end of the day, if to have a vehicle manufacturer to be able to provide that data back, he's really essentially got to take on data rights, and that's a big issue we have at the moment there too as well. So a lot of these nuances, whether it's the legal responsibility around the data itself, the expectation of liability with self-driving cars, these are the things which are going to slow it down a little bit, and we have to solve before this thing will get to scale.
So I would say summarize that scaling and standardization is 2 of the biggest problems you highlight. So look at scaling is a common theme between the 3 of you guys in regards to one of the biggest problem with HD mapping. And we are in a 5G and edge computing symposium just by coincidence. So how does the 5G and the edge computing really help in that scaling standpoint?
So for 2 of those problems, I think that I mentioned originally, it really helps. One is for an update, because what's actually pretty beautiful about mapping for edge computing is that all of the data is geospatially referenced. Like, you only need that map data for the area you're in. So you can talk right to the edge and just talk to that node and not have to go all the way to the cloud. So from an update perspective, the sensor data can get aggregated at the edge. It doesn't have to go all the way to the cloud. And then updates can be dispersed to the other devices in that area. So that's for the updating. For the localization problem, you can also use that as a method to not have to send all of the data down to the device, but perhaps send some data to the intermediate edge and do some localization there. I think ideally you do most of the localization right on the device, but there could be some localization done at that edge node.
Yeah, I was just going to say, we about 3 years ago now, we together with Daimler, BMW, and Audi, started to actually create what we call connected vehicle services, where the exact problem where you have basically a vehicle which could actually have some data which is indicating issues on the road. For example, if the windscreen wipers are on, then potentially it's a wet road you're driving through. If the hazard lighting button was pushed, there's potentially a pile-up, aggressive braking, etc. So that data, the sensors in the car, which basically are identifying this, is really valuable. And we actually worked with these 3 OEMs to then take that data to try to actually derive what that meant and inferred, and then to anonymize that and then pump that quickly to vehicles behind. And we've actually got that deployed now. We call it Connected Vehicle Services. We have a hazard warnings product and some others as well, lane level traffic. We've really learned a lot from this. Latency is a big issue, of course, because ultimately, whether it's going to be with mobile edge compute happening on the edge or potentially going back up to a cloud vendor. And of course, you've got different parties involved there. It's the OEM's cloud, to our cloud or to back to another OEM's cloud. So this is really interesting stuff. And it's super difficult to do and to resolve. And then, of course, scaling it out. So I think I couldn't agree more that that stuff is really key. The other thing about updating maps as well, ultimately, too, it should get to a point where if, for example, we have this concept of a self-healing map, that ultimately the map, whether it be actually on the client side or potentially in the cloud, to make decisions themselves about what's actually an update or an issue. An example could be basically if all of a sudden the map has seen a different traffic signal. It could be a stop sign was there last week, but it's not there now. How many times do we need to see that before we actually make the change in the map? Or potentially if you see a signal but it's obstructed by something else, can you actually tell other cars to look at that set signal as well? So it's a very interactive way of dealing with the edge as well, and all that stuff happening on the edge side of things. So it's some really interesting stuff, and we're trying to together as an industry tackle.
So, and also for our solution, so we have a demo booth here, so you can see we're actually using drones to collect such map. So I think one specific thing we can really benefit from the wireless 5G and the edge is that we can use the drone as a flying camera with a very light computation, stream the 4K video to edge server. On the edge server, we can do the map update, we can do the aggregation. We also to provide the real-time road condition update. All these things are additional inputs to the map, and update the map also provide the real-time guidance to the traffic, to the vehicle navigation system. So how many have you sit in the traffic and wonder what's happening ahead of you? Is it due to construction, due to the traffic accidents? You never know how fast, how long they will last over there. So I think in this case, we literally observe the world from the drone perspective, from a different perspective, provide the the different elements to add on to this big map, live HD map.
Yeah. So I'm going to. I think you guys talked about latency and real-time aspect. Let me pick on the real-time aspect first, because from the OEM standpoint, one is to localize the car exactly to centimeter level, at the same time having extremely super high accuracy standard map layer. But at the same time, when a vehicle is driving and multiple vehicles are connected together, I want a capability where, let's say you have a super emergency scenario somewhere, and the vehicle localized should know either it's a severe weather or there's an emergency first responder and all those sort of things. Does the edge help in that standpoint rather than having a cloud, central cloud?
Well, I think that goes to the being able to use the edge to then disperse updates with higher latency to vehicles in the nearby area. I think also it's not just sending from one vehicle to vehicle, but as was mentioned, it's the aggregation process as well, where it helps to have compute closer to the device. So you can do the aggregation there. It doesn't have to go all the way up to the cloud before making the decision.
But how do we solve that? I mean, is there a silver bullet we can solve the dynamic behavior of an HD map? Is drones the ultimate solution, or else Scott's other solution?
Well, the other thing too, I think we're talking about the near future here as well, and you guys in the room know better than I would personally, but 5G is going to take a long time to roll out, and so we're going to have a situation where there's going to be multiple different types of connectivity and networks available. So, and again, you're going to have a situation where vehicles go outside of coverage areas as well. So there's all this stuff happening, which ultimately, whether it's the vehicle itself needs to understand where it is, where it's going to, and luckily it does. Usually it understands the destination, so it can figure out and start to make decisions about if it's going out of coverage area to be able to download and cache, the map for that route with potentially a buffer, either side of it. But it's going to happen on LTE, it's going to happen on 5G. So I think ultimately, being able to actually develop systems which are able to manage different types of connectivity, even understanding where the coverage bounds are. We've just recently launched a product which is called Cellular Signals, where because we have a positioning engine as well, and we're able to globally, we have about 3.8 billion Wi-Fi hotspots and about 700,000 cell towers, which is the existing infrastructure out there. We're able to know what the bounds are of the current coverage and begin to understand if the vehicle's going outside of that area for the next hour or two, then be able to quickly cache onto the vehicle, the latest version of the map. So my point here is it's going to be, I think ultimately there's going to be quite a few different ways to manage different types of connectivity and have that redundancy in there.
So I get that. So connectivity, we can have multiple different ways to do that. And we were talking earlier in the beginning of the day today is that either the 5G or a Wi-Fi or other technology connect together. So but my question was mainly about the dynamic behavior of events happening in real time. Let's say there's an accident on the road. And I want the cars only in the surrounding area to know that accident. And also, let's say there's a 6-inch or a 2 feet snow in the northeast area. So I only want those vehicles to be affected, but then not the other vehicle to be affected. How does one of your technology helps that, we would say?
So from our perspective, later perspective, we developed technology to combine the 3D vision and deep learning to understanding the moving objects on the road. So we know the type of these objects, we know their exact motion pattern. So in this, you can definitely provide guidance to tell you there's a slowdown in a certain area, there's something like a bookshelf lying on the road, those kind of things. So our belief is that, so let me describe a kind of sci-fi, but actually quite a technical approach that we can do today. That is, we have the autonomous drones flying around along a certain pre-designed route. So I just need to, for example, I just go fly over the certain section of Highway 280. Usually there's a rush hour jam over there. Detect anything that's peculiar, that's actually abnormal, and then send that data to a central hub, so you can be edge server nearby. And all the cars that are in the nearby region, they subscribe to this update, and then they use that to guide their driving behavior. So that's what we're seeing like at real time, what we can really provide. So in this case, of course, we would like to have wireless 5G, but even the current LTE, it also works as long as we are connected with the network. We see something, we process the sensor data on the drone, and then send out the vectorized information to the nearby servers. And another thing, I think probably like a quite easy to understand technical details that it's very simple to divide the world into tiles, and then each kind of edge server is manage a certain number of map tiles, and a lot of things can happen on each a number of tiles. Yeah.
So if I paraphrase and understand technology, so for the Foresight AI, the drones will capture the real-time video, send it to the cloud, and the vehicles driving around will latch onto that and then ping and say, okay, is there an emergency scenario or a severe weather or something like that?
Yeah.
Is that something similar you guys do, Scott?
We don't operate a drone fleet. We believe that for edge updates, you can get that from the current vehicles on the road and use that camera data for edge purposes.
Okay.
Yeah.
I think, we definitely have a view that any kind of data we can get we'll actually use if it's possible, because what we're learning very quickly in this industry is that ultimately there was a vision or a belief 3 years ago that HD maps weren't needed in autonomous technology. It's to the point where there's amazing active sensors on a vehicle, whether it be cameras, radar, potentially LiDAR, and those active sensors are sufficient to be able to provide basically an autonomous experience. What's happened is, of course, and this is one of the things we've been talked to so far, is that for standard definition maps, you can be at a service level agreement with your customers around about 95, maybe 96% right, because maps do change quite a lot, and so you're never going to get a situation where you can make a guarantee on better accuracy than that potentially, and we all know that because we all have this every 1 in every 10 incidents with with a current mapping service, you're going to have some disappointment. But for autonomous deployments, we're talking 4 nines potentially, and it's going to need to be, the bar is that much higher. So every sensor you possibly can get, whether it's basically active sensors on the vehicle or the passive sensor being the HD map, is going to be important because weather incidents, if the camera's blocked, obstruction, the vehicle needs to know what's happening around it. And I think this is getting to the vehicle-to-vehicle stuff is ultimately too, is that, and I'm a big cyclist, so I'm very passionate about in 5 to 10 years' time, I'm hoping there are no fatalities on the road. 40% of the fatalities in the US happen from rear-end collisions, so people basically are driving up behind a car they didn't see, bike that is, and didn't see. And so ultimately, if you're able to take, and most of those cyclists have got sensors on the site, which are connected, by the way, because they're all basically tracking themselves in various apps. If you can actually take that data, because often what's happening is a vehicle, even if it's got cameras and stuff, might not see that cyclist at the last minute. So knowing potentially around the corner, there is potentially a hazard. There's a group of cyclists coming up. That's the vehicle-to-vehicle edge stuff, which is nothing apart from having edge compute is going to allow that to really understand, because you can't see around that corner. There's dynamic data there, potential hazard, and so that's the use cases I think which are really edgy, but the ones that are going to be important for this to be successful.
Yeah, that's a nice segue. What I wanted to ask, basically, the next question. So in the previous panel, which is the county and the role, and we were having lunch together, that oftentimes this is also a system integration issue, like the map and the OEM together. I mean, you can't just have it, solve it all by yourself. So what your guys' take is that how can the OEM or the car maker or maybe a standardization can help out? Anybody wants to open for anybody? Yeah?
So I mentioned before there's some standardization efforts underway. There's one standardization effort called Sensoris, which actually is well attended now. It used to be, it's actually now run by Ertico, which is the Intelligent Transportation Systems body in Europe. And if you look at the members there, you're looking at system vendors, you're looking at OEMs, you're looking at HD map companies. Everyone's involved there and trying to come up with a standard to be able to process that sensor data that's just coming out of the vehicles. So I think that's the kind of stuff which ultimately is needed for us to do that solve.
Yeah, and I'll add something to that. We've kind of broken our map format into 2. One is our internal map format that we've designed to be as easy to update as possible. And then we have a compiled version. And that would be that's more of the runtime. And I think it's important to keep those decoupled because it's very difficult to update that combined version already because everything's all coupled together at that point. So we've specifically separated those 2 and architected our base map format for easy updates.
And also probably quite common that every company itself has a superset of formats. Then there's for the lack of a better format, a lot of people using OpenDrive is one of the open source exchange format. We're not happy about that, so hope to kind of work together to really define the format. So I think also, my view is that the format itself is really kind of the really technical aspects is less important. The more important is what kind of information do you need for the vehicle to operate. Like when you localize, do you need the 3D point cloud? Do you need just a vector format? And also, do you need color images? All these things has to stabilize very soon. Otherwise, we all just sitting on a single island.
Yeah, I mean, other thing we're also working on is that oftentimes there's a vehicle-to-vehicle connectivity, and even within that, we work with 2 technologies which is competing to each other, and probably some of you guys know that. There's something called DSRC, which is a short-range spectrum to communicate between the vehicle. There's also CV2X, which is competing technology. And oftentimes, those are technologies needed for safety of the vehicle, and no standardization actually is making roads more unsafe. That's my point of view. But the question I want to lead on to that, if we are working on some of those technologies from the OEM standpoint, does it help overall to really have the vehicle talk to each other and also the edge, and also help in terms of updating the HD map in the real time? Scott, I'll leave it to you.
I'll ask the question.
So I think from start, we need everything to be connected. Otherwise, the drone will be flying in the sky with nobody to talk to. So yes, I think we definitely will, our company, our technology will definitely benefit a lot from a common, well-understood, connected protocol, so we can inject information in a confident way. So also, as you can understand, not every piece of sensor data is created equal. Some has high confidence. You're more likely to use that. Some at a particular time that you just lost GPS signal, then the corresponding LiDAR points, you cannot use it because you don't know where they correspond to. So we hope to inject more semantic information of what you observe, what we observe, into the vehicle system as well, so that we can just plug in more information into vehicles, into infrastructure. Also, of course, we don't want to be like a big brother in the sky. We don't want to be like that. We provide a lot of guidance that all the vehicles can use to better optimize your solution.
Yeah, I was thinking that through. I think it comes down to use case as well. Like, within autonomous vehicles at the moment, there's two major use cases. There's what's called HAD, highly autonomous driving, and FAD, fully autonomous driving. That's becoming, industry buzzwords we're using now. So fully autonomous driving is, of course, level 5, but it's also meaning on every road in the network. So functional road classes 1 through to the smallest streets you have. So the major highways all the way down to an urban road. What's happening at the moment is level 2 and 3. This is really where the market's at. Most of the OEMs are, in the next year or two, going to deploy some kind of level 2, potentially 3 capability, and that's going to run on major roads. That's going to be basically autonomous technology running on highways, all the way through to your major, what we call a functional road class 1 and 2, potentially 3. The kind of real-time data you can get from that, I think we could probably, and that's why it's going to happen on those roads to start with, is you can, have good infrastructure. You can actually have the vehicle-to-vehicle components to it. What gets tricky, of course, is when you come off that into 4s and 5s, the fully autonomous stuff. That's really hard because there's so many variables in those streets. There's so many things happening that it's very difficult for a machine to make decisions at the level we need them to. And it's interesting because the market's split in two as well. You've got pretty much the OEMs who are focused on having to allow someone to purchase a vehicle and to drive on these roads, as opposed to on the other spectrum, which is more on-demand players, the Lyfts, the Ubers, who are at an advantage because every dispatch they do on their network, they know the origin and destination, so they can figure out basically whether someone can actually drive that, or potentially can we take an autonomous vehicle down that road. So, but that's fully autonomous stuff. That's really tough to do. So I think as things pan out, the different data sets you need and the kind of level of attribution required to have both those type of use cases supported is going to be really interesting. That's what we're thinking a lot about too now, because ultimately our program, we've got literally a dozen OEMs now we're about to launch with in the next year or two, with a fairly good coverage of our data, HD map data. It's all about those hard autonomous driving on the 1s to 3s, the high-end roads. We're thinking deeply about the fully autonomous stuff now, and it's a lot harder to solve. And that's really where I think our efforts are going to be in the next couple of years.
Yeah, and for us, we've been focusing on the city mapping, which is the fully autonomous driving sector. So we've mapped San Francisco as a test, and we're mapping a European city as well. And I think it's important to distinguish the two market segments. One is the robo-taxi, which can launch by geographic city. So you just need to map one particular area, like San Francisco, and that would open up that type of market. And then there's more of the highway, Tesla, advanced driver assistance approach.
Awesome. I'm loving this discussion, and it seems like we can all benefit from each other. One thing I want to touch upon, which I said latency, because we talked about scaling, localization, standardization, dynamic events or so. So in terms of 5G and edge computing symposium we are here, what kind of latency you guys think that is possible with HD map, which is you're adding more and more high definition into the map. So you're kind of making the data size much, much bigger. But at the same time, you need much more lower latency. And isn't this harder problem we are going after? And what kind of latency you guys think is possible?
So I think it's important when we're talking about the size of the map to distinguish the two types of maps that are used. One is the HD semantic map. So here's where all the signs, signals, lane markings, all of that detailed information is. And then there's the localization map, which is what the LiDAR or the cameras are using to compare against to place themselves on the map. Now, sometimes they use just the 3D semantic map for localization, but a lot of the actual self-driving cars use something like an occupancy grid or something, which is a subsampled LiDAR point cloud to do the localization. So that's something that we've also focused on, is how can we take that type of data and compress it so that you can have localization at scale. Because if you rely on a laser scan essentially as your reference map for localization, then that's why you look in those cars and they have, in the trunk, they have all those storage arrays. Because they're storing all of that data so that they can do localization.
But with all that complexity, is there a latency number you guys have in mind? Or you guys think that?
From an update perspective.
Yeah.
That's a hard number to like come up with. We're trying to drive it, drive it lower.
Yep.
Can I frame this in a way?
Yeah.
60 miles an hour
Yeah.
is 90 feet a second, right? The typical Azure or AWS latency is 100 milliseconds, so it's 10. So at 60 miles an hour, a car's going to go 9 feet. So if you had 0 latency, that's a 9-foot playback. How many of the applications you were talking about care about 9 feet? Because, you know, if you're talking, I'm going around a bend, that's not 9 feet, that's probably 30 feet or 90 feet. So, you know, for this edge hosting to really make sense, my basic calculation says it's got to be a sub 9-foot decision.
So
Plus maybe braking.
I was going to open up for the audience in 5 minutes or so. But quick one. So 9 feet accuracy is actually pretty big for us from the AV standpoint, from these guys' standpoint. So it's actually much lower from the distance standpoint, accuracy needed from the SD standpoint.
So I think that's a great point, which is what are we measuring? Are we measuring the real-time localization? In that case, yeah, you can always do the back of the envelope. If you're going 10 meters per second, you have 100 milliseconds. That gives you 1 meter. So it's like it really does matter. If we're talking more about latency of updates, then it can be how fast does the scene change? So then that's sort of your function. But yes, if you're performing localization or real-time detections, then yes, it has to be very quick.
So I think this latency, there are 2 latencies. One is the customer consuming the data. So it would be I'm honest, it would be crazy you think about, I don't have the cache of the map. I always done it on the fly. That's not a good engineering approach, right? So in that case, I would say it's less latency critical per se, right? Of course, you want to, it's a function of first, how fast you're moving, how much of the data you want to download. If I'm driving on Highway I-5 from Seattle down to Los Angeles, well, how much data do you need, and how big is your hard disk in your trunk, right? So all this can be calculated. I think what we found out is that the second latency, which is super critical, which is the map generation or the collection latency. So in our approach, we need to collect data, the color images, LiDAR scans, GPS signal, all this data. We need to collect them, stream to an edge server at a high-speed, low-latency manner, so we can optimize our flight path. I'm talking about our drone operations. So in that case, if I fly around, I capture data, I process on the fly. I may find gaps. There's a gaps because of occlusion, because of many things. Then we know what to capture, I probably want to go back again to capture data. So this latency or the speed is super critical for us to generating the data, aggregating the map, updating the map. As for the consumption, we haven't seen the full whole America highway data yet. I mean, for the level 3 or even higher. So in that case, it's really hard to predict. But I think it's as fast as possible. But I think it will be crazy to say, oh, we need a 10 millisecond for now. I think that's also not a realistic number to target at.
Any point?
Nothing more.
Okay, so I'm going to open up in a few minutes or so for the audience, but I have a fun question for all of you guys. Yesterday, Andrew Keen was actually in the afternoon session. He said that if in San Francisco or Bay Area you say 15 to 20 years prediction, you don't know what you're talking about. So my question is that, let's say, assuming that you have the crystal ball and you want to really update the SD mapping industry, in 5 years, how do you want it to look like? Start with you, Scott, and then go.
I would think that it's the key cities are mapped for robo-taxis to enable that deployment. I don't think you're going to have full deployment definitely at that time. And you're going to have some level of updating from the cameras that are currently in the market, to either to update it or to just flag, here are some problem areas, you can't rely on the maps. I think that's a realistic goal in 5 years, and have that at least be a daily update to enable then deployment in those areas.
So in 5 years, what we envision is that on top of many parking structures, we create a drone depot. We have 4 or 8 autonomous drones. They fly out every half an hour on a pre-designed route to scan around the street to identify the updates, if there's something missing or there's a car getting jammed, and provide that data, integrate with the existing map data and the traffic information, so that we always have a really live update of the city, how city is running or other places. And then, yeah, I think also basically at that time, probably don't need a human intervention, everything automatically. So as a human, you don't have to move anywhere. You just kind of have the data served to you.
Yeah, I think that's the point for us too. I was thinking this through. Like ultimately, at the moment, HD mapping, the way to solve it is industrial. It's essentially you have to start with something. So essentially, we today have 400 vehicles on the road, which what we call the here true vehicles with full capture, LiDAR, differential GPS, initial measurement units, high resolution cameras. These are very expensive, capital intensive vehicles out there collecting 140 gigabytes of data per day, which by itself needs to be sent up into a cloud, because at the moment we're shipping hard drives. But that's because we need to actually start with something. And we envisage in 5 years' time that if we can crack the sensor issue with the vehicles and be able to have the vehicles themselves be able to maintain that data set which we originally built using industrial techniques, then essentially we don't have to have these vehicles driving around the road. So that's the one we're hoping to crack. Human intervention is a really interesting one, because ultimately, again, back to these 4 nines, to get the level of accuracy we needed on this stuff, there's going to be instances where a machine just can't, no matter how much training they've got, there's certain scenarios which, for the map itself needs to be resolved. And so it's an expensive part of the business. We have 4,500 people in India, which we have, that help to maintain our maps. And this kind of like curated efforts are required. And I can see that going away for sure. Whether it goes away totally, I'm not too sure. But yeah, so I think, having this ultimate vision of a machine to machine, getting into the point where we can build this kind of coverage needed. Because once you have that happening, it's going to scale quickly. Moore's law, everything's going quickly. If you look at, again, looking back, it took the company I work for now, let me think, 18 years to build out a map of the US and to actually make money from that map. That's a long time. It's a long, so the first maps that Here Technologies built in the US started in the Valley actually in 1988. And it was really around 2000, 2003 when that was complete, and we actually started to actually, get a dime from that effort. But that was back, when you use Moore's law, the processing power, the capacity, what we needed to do then. Things are getting very, very quick. It's amazing how fast things are going now. So I think within 5 years' time, we'd be surprised if we can crack this sensor issue and begin to work with OEMs and open that up. So we actually have, today we currently have, I mentioned before, we're working with different OEMs to take the deep sensor data out. We've got about 1.3 million vehicles, which we're leveraging to maintain our HD map. It's nowhere near enough. But if you mentioned before 100 million vehicles connected by that time, with all that data that's coming through, that will actually scale very quickly. So it's really about getting the standardization right, getting to the point where we can leverage that scale. And I think it won't take much longer to get this world map properly. Yeah.
Awesome, guys. I love it. And thank you, all of you. But it's no doubt in my mind that we all have to work together. It's a harder problem to solve. You guys, OEMs, the 5G, edge computing, AT&T, Ericsson, we all can benefit from each other. And there's absolutely no downside to that. It's a win-win. The final question from my side, let's say you're not working on HD mapping. What is the single most game changer technology you want to work on for AV, ADAS standpoint or so? 30 seconds and closing.
So I think like the dirty little secret of the AV industry is the remote operator, where they're streaming video data and then close in the network, somebody is actually getting themselves out of that edge case. I think that's also happening for robotics like delivery robots. So I think that's kind of an exciting sub area that I'm watching from afar.
What about each one?
So in the day I work on mapping. At night I try to work on motion planning. So motion planning is one of the most challenging problems for robots. What it does is look at the world around you, try to look at how these things moving, especially unpredicted humans, how they move in the past 5 seconds, and predict how I should move in the next 5 seconds. And you have to make such decisions usually under 20 milliseconds. So that's a very challenging problem. We're actually exactly trying to generate data to solve that. But usually every night I try to solve that problem myself. So it's a very simple.
It's a lot of work.
Yeah, it is. Basically, is a simple term is AlphaGo for autonomous driving. Yeah.
For us, ultimately, the HD map for the autonomous use case in a vehicle is taking quite a while. So we're now thinking very deeply about how to take that same data set and apply that in industries and use cases, like whether it's insurance, taking 3D point clouds and be able to help an insurance company decide with the risk factor on a certain house, looking at the pitch of the roof, the height of the first step, etc. Hugely impactful in an industry that hasn't been disrupted for 30 years. We're still taking your postcode and address and giving you a premium quote. Through to a studio company who needs to do a shoot, wants to understand the line of sight potentially and have that all mapped out before they go into the real world to map that. There's this amazing use cases out there for the same product which has been built with a autonomous vehicle in mind. And this is important for us too. I think at the end of the day, the business case required to build this stuff is pretty significant. And for it to be on one use case in one industry is just way too, it's not a business case which is very, very effective. So we're looking very much extending it out there. We're thinking very deeply about each of the industries that we cover and making sure we have a product which is fit for that.
Yeah. The question was giveaway from my standpoint because I began by saying that for us it's not an either-or problem, but the 5G and edge is actually the technology we need from the OEM standpoint because of the connectivity issue and the bandwidth of data and all those sort of things. If I'm not working on HD map, but if I'm not working on that, I would be working on 5G and edge. So with that, I'm going to open up for questions. Elena, how many questions we can have?
Yeah.
5 minutes? Oh, 5. Okay.
Like
Okay.
10 minutes or so.
Okay.
Got one for you, Dr. Corey. Just turn your own question back on yourself.
Yep.
So you asked them what latency they could provide. What do you need?
So it is, as they answer that, we don't have that answer. I'm trying to find that answer myself. The real latency needed is 0. It's as fast as possible or so. But in regards to the ADAS and other vehicle, we usually have 20 milliseconds from the safety standpoint when we actually tune our vehicle from the safety. Either you're going to have ABS and other things. We usually have 20 milliseconds or lower. But with all the complexity coming into the play with HD mapping and everything else, we still need to keep that 20 milliseconds. It's a really, really hard problem for us to solve. So we are trying to find out how much we can really get with all the complexity coming in. I don't have that answer.
So another way to talk about it is if there's a hazard on the road and you're driving down the road toward that, how far in advance are you loading that map for that particular spot? Is it 60 seconds in advance or something? I mean, in that case, latency is not so critical, right?
So for that, actually, I need help from these guys for loading the map and then having it really, really nimble mapping system, as you guys, which can load quickly but still have high definition for an AV to make the quick decision. Besides the safety standpoint.
Okay. Yeah. Any other comments?
It's a network. At the end of the day, you're going to have a map to start with. So you'll have some version of reality which is in the vehicle. If the sensor's seeing something different, then that's when it's getting interesting because ultimately it needs to potentially inform vehicles behind, format and process that update or that change detection which has been identified there. But I think we've again teasing this out before. There's going to be a combination of both. You can't potentially have this whole thing because the latency is just insane. It just can't happen without actually the vehicle itself having on the client side enough of ability to get through that next 60 seconds. It's just I don't think it's going to be a situation where it needs to do that. The other thing that's interesting too about time and latency is we talked a bit over lunch. Is that you've got 5 levels of autonomy that the SAE have defined. There's a big debate now, of course, about what's going to happen between 2 and 3, where we're kind of at now, to 5, which is fully autonomous. Because ultimately, one of the things we did some studies about 2 years ago, where we looked at, basically if you're driving along reading an email, not really cognitizing what's going on with the road, and all of a sudden the vehicle wants to take control again, it takes anywhere between 25 to 40 seconds for someone to actually be able to stop what they were doing, understand where everyone is. There's no way you can
mean
actually...
20 to 40 milliseconds, not seconds?
No, seconds for a driver. This is the problem at the moment. We have the situation where the industry is very much looking at this carefully, because ultimately some believe that we have to go to full level 5. You just can't have a situation in between, because it's impossible for a driver to be able to take control of a vehicle, because it takes that much longer to understand the environments around them. So I think, yeah, this is stuff which it's down to seconds. It's down to, if not, again, we're talking about what's happening at the moment in the aero industry or nautical industry. This stuff that you can't have, where you got to press 3 buttons to be able to take control again. It's that's the use case, I think, or the constraints which we're dealing with. It's really it's very instantaneous stuff. Yeah.
Very good question. Unfortunately, there's no silver bullet and correct answer, so that's why it's so hard problem to solve. We all have to work together. So more questions?
So one of the problem spaces is the storage of the data, right? So since it's sensitive geographically, how much of it is a private cloud versus a public cloud? So it might also be an OEM question.
Yeah. We find that as an OEM question. At the moment, it's a big debate internally for us, because cloud infrastructure is a arms race going on, particularly around the OEMs. It's one which you'll probably have to be able to do multi-cloud in the way you support the map infrastructure and run it on infrastructures that are basically prescribed by your customer, being the OEM. So I think it's a combination. You have to be able to support multiple.
So I'll answer in a minute. Anybody else want to chime in for that question, for the storage?
So as a young startup, we haven't meet the blocker issue of the storage yet, but I think definitely should be distributed and then maintained by third party, I should say, like not us, right? So it's some either paid by our customer or working with some other collaborators. They operate the edge network with the storage compute setup over there. So we like rent real estate over there.
Mm-hmm.
Yeah, and I'll add, different countries do have different, because this data have applications to national security. Different countries do not allow any of this sensor data to leave the country. Yeah. So we've actually we have a kind of a cookie cutter data center that we can go and set up in a new location and just have all the mapping done in that country instead of relying on cloud computing or third-party cloud. And I think that's strategic.
So that's a very nice question. And from the OEM standpoint, storage is also a big issue for us. But at the same time, Scott has mentioned that nobody like you or me, I don't want to have NVIDIA GPU sitting in my back trunk and then driving with that all the time and then have it all the compute capability and everything else. That's why edge is so important for us. For us, like the vehicle will latch onto an edge which is closer to the roadside unit. By the way, the way we define edge is not the car, but something which is roadside unit or so. And the vehicle can latch onto that edge, and that edge does majority of horsepower and compute. And the vehicle is not something which you're driving with a big storage capacity or something like that. So for us, that's why it's not an either-or problem. It's really a must-have problem, particularly with all the connectivity and the complexity going into the car also. But not definitely is going to be the full compute capability and storage in the car. It's somewhere outside of the car, but closer to the road.
I think also Chang mentioned at the start of the session as well, this is a very individualistic thing. So driver behavior is all down to that person as well. So, there's a whole lot of issues we're dealing with now to understand what you prefer autonomous vehicle to behave like versus your wife, or it's a very different situation. So, it's not just storage capacity. There's a lot of ways of having identifiers, GDPR. The whole thing becomes really quite a big interest in being able to actually provide that kind of personalized service within a GDPR constrained world with storage issues. So it's
privacy and all those things is big. Very nice. Any other questions? Yeah, absolutely.
First of all, thank you so much for sharing your views and latest technology. And I have a question about for Chang. So what is the pros and cons of running the drone fleet compared to vehicle fleets for data collection?
Sure, definitely. So first, I worked on that because it was my PhD thesis, so I knew the powerfulness of drones. I looked at the drone footage for 4 years. I definitely enjoyed that. I think our view is that the drone turns out to be the most advanced robot to date. It's not actually, again, it's not sci-fi. As of today, on my computer, I can click a button, or I don't have to click a button, actually can automate it, that the drone can fly out, collect data, stream out the data, and get everything processed. I think basically we are relying on the most advanced robot to help the other robots. It's like some kids, they're very smart. They teach all the other kids, come on, I teach you. This is how the world looks like, how people drive. So that's why we're using drones. The limitation of drones is that, indeed, there are places we cannot fly drones. So we cannot fly over White House. We cannot fly over airport. There are also, flying over the busy street, always be careful. So there are places that we try not to fly and rely on the vehicle solution. So again, I don't claim we can use drones to solve everything, but I think in the areas that we can fly drones, I believe is the most efficient solution. And sorry, one more thing is that also for the driving scenarios, if you have a car on the road, you cannot observe the whole driving scenario around you. Usually you get occluded by we usually call the first ring of vehicles around you. But from the sky, we can see all the crazy things happening, and then we can load that data into the simulator so that so we can work on motion planning algorithm.
So do we have more?
We have time for a few more.
Okay.
If there are any questions.
This is the last session, guys, if you want to ask any questions to the panelists. Okay, so I'm going to actually close by saying thank you again to AT&T, Ericsson, and all those guys. Actually, this is so much effort you guys have put together. At the same time, Kirk, Chuan, Scott, you guys have taken so much time out of your busy schedule or so. And thank you guys being such a nice audience. So with that, I think it's an open floor. We can walk around, and there's still a display.
We have closing remarks from
okay.
AT&T and Ericsson leadership.
Okay. Thank you, guys. Yeah, thank you.